Hey, welcome. Okay, then I guess we're live. Welcome to the GopherCon 2020 Lightning Talks. I'm Mark Bates. Thank you, Brian and Eric. I appreciate it. And welcome. We're very excited. Now, this is one of oh, what? This is one of my favorite events at GopherCon, and I'm really glad that this particular event is being streamed live, regardless whether you have a ticket or not. And every year, this is one of my favorite events in person, and obviously we can't do that this year. But I do want to very quickly just talk about why I love the lightning talks and why I want to make sure that you give our speakers today and on Friday, and I'll get back to that in a minute, that you give them the time that they deserve for their talks. So, when I get to do this every year in person, it's really fun. I mean, I usually get to do something like 35, 36 talks in one day. That's 35, 36 gophers that we get to hear from the community. And that's what's great about the lightning talks. It's usually new voices. It's people who don't get a chance to get on the big stage. They get to talk about some of the things that are passionate to them. And I've seen a lot of speakers go from the lightning talk stage to the GopherCon main stage. So it's a wonderful place to hear from these new voices in the Go community. And we always need to hear from new people, and we need to hear new diverse ideas and opinions and thoughts, because that's how we grow as a community and as a world. And the other thing I love about GopherCon Lightning Talks is the passion. These are all people who are very passionate about what they're talking about. And to hear that passion and to see that passion for 7 minutes is just wonderful. So I really hope you'll join me in extending the next 45 minutes of your time to all these great speakers we have lined up. Listen to them, hear what they have to say. You might not always agree with what they're saying, and you might not use the library they wrote or the thing they're talking about. But listen for their passion and listen for their excitement in their voice, because that's how we go from here to there as a community. And that's how we've gone 11 years. Happy birthday, Go. And that's how we'll make the next 11 years. So with that said, on to the rules, because everybody loves a few rules. We're doing a broadcast today, and we're doing a broadcast on Friday as well. Today, we're doing 45 minutes, and then on Friday, we're going to do a full hour. So if you want to find out what time on Friday we're going to be doing that in your neck of the woods, I recommend going to gophercon.com. You can find the agenda, not just for the lightning talks on Friday, but for the rest of the conference as well. There's a lot of great talks and a lot of great stuff happening over the next few days. And if you want to give a lightning talk on Friday, please go to gophercon.com as well. And there's more information on how you can sign up for Friday. So the rules, here we go. Getting into the meat of it now. The speakers each have 7 minutes. It's like a game show. They each have 7 minutes to talk about what they want to talk about. And of course, we're going to make sure these are all code of conduct compliant, and everybody's just going to be sharing some really exciting stuff. So they have 7 minutes to talk about their passion. And at 6 minutes, with 1 minute remaining, they'll get a little screen and a little ding that looks like, well, that was great. Thank you, Jose. And then finally, the last few seconds of their talk, they're going to get a curtain that's going to go something like this. It's going to shut them off, and no matter what they do, yeah, well, you didn't need to see that close to my face, let's be honest. So with that said, let's bring up our very first speaker, an old dear friend of mine, Mr. Ron Evans. How you doing, buddy?
Hey, Mark, how you doing?
Great, man. It's been a long time. Where are you calling us from?
So I am calling from the lovely northern steeps of Stockholm, Sweden today.
Oh, that's unusual. You do live in Spain, so...
Yes. Well, it's I'm up here doing mysterious things with very large pieces of equipment.
Who isn't these days?
More on that in a future talk.
Fantastic.
But I was just thinking, I am one of the people who's the opposite that you were describing. You were saying people go from their lightning talk to the main stage. I guess I'm one of those people who went from the main stage to the lightning talk. So,
what does that tell you, Ron?
I'm shrinking.
You're the incredible shrinking programmer. I for one. So normally, we get to do this lovely banter on stage in person, and normally you try to kill me with some sort of a drone strike.
I sent a drone. It's still on its way.
Yeah, well, that's what they all say. But thankfully, I am safely ensconced right here in my own home studio, and there's no way you can possibly, Ron. Now this is not playing well, is it? My little drone strike. Okay, I'm gonna stop with the comedy, if
That was
that's what that
comedy?
was, and
I
I'm
was
gonna.
being serious.
I know you were. That's the scary part. So I'm gonna throw it over to Ron Evans now to give you a small update on TinyGo.
Hey, all right. Hi, everybody. A small update on TinyGo. So I am Ron Evans, aka Dead Program on the internets, technologist for hire, also technologist on the at large, technologist in exile. Call it what you want. I'm with the Hybrid Group. We are a boutique consultancy who creates software for hardware companies, all technologists for hire. So I'm here to tell you about TinyGo. So TinyGo is a Go compiler for small places, you know, the little tiny places. And it's now sponsored by Google. Thank you very much, Google. You're keeping us alive out here. So the current stats of the TinyGo software, 7,100 stars. That's over 7,000 stars on GitHub, 345 forks, over 70 contributors, and 46 different boards supported. Yes, that is 46. That is the correct number we counted. We counted twice. 46 is the correct number. Just thought I'd let you know. All right, so let's talk about the TinyGo release 0.16, which is about to come out. LLVM 11 support, the latest version of that, powering both Rust, Swift, and of course TinyGo. More and better standard library support for Go. WebAssembly, including WASI support. In fact, people are using non-web browser WASI Envoy plugins and other things using TinyGo now. And ESP32 and ESP8266, which are the most popular Wi-Fi chips in the world, with I don't know how many billion served. So TinyGo in the world. Let's talk about some of the really interesting things that people out there are doing. So from Brazil, TinyGo on Nintendo Switch from Lucas Teskey, aka Racer XDL. So he's been making a number of really remarkable contributions on the Nintendo Switch. And this is actually running TinyGo right on the Switch itself with no additional software. This is pure Go running on the Nintendo Switch. It's really pretty amazing that he can render graphics. So lots more interesting things to come from our Brazilian contingent. So let's go back to Japan, where we can write TinyGo code on Android now, thanks to Takasago-san, one of our team members and a very, very serious contributor. So he's going to use an Android tablet in this video to program a SEEEDSTUDIO XIAO, which is a very, very small board. So yes, it is now possible to write TinyGo programs on Android. So let's see if we can find the video. And so this video here in YouTube is showing Takasago-san, if we programming on, oh, no, not you, Mark. So this is Takasago-san's Android tablet, and he's got it plugged into the XIAO microcontroller board. So he's cross-compiling TinyGo code from the Android tablet to program the microcontroller. I don't know how much smaller you can get. I mean, that's a pretty tiny keyboard. So we'll just jump forward, and now he's running the Go program on this little tiny chip here. So it's pretty amazing the things you can do with Go. Go, it's everywhere you want to be. All right, so let's go back to our slides. So then moving on to somewhere on planet Earth, I don't even know where, TinyGo on the Teensy 4.0 from Andrew. So the Teensy 4.0 is an MXP ARM Cortex M7 chip, and we're going to see it running on this little ILI 9341 display at 120 frames per second. That's pretty quick. So let's see if we can find the video. So Andrew is doing some pretty amazing stuff. So this video here, it's running on the display at 120 frames per second off of another connected microcontroller, the Teensy 4.0, which is a very, very small microcontroller, although very powerful. It runs at 600 megahertz. So it can do quite a lot for such a small chip. And then last, the Go badge, featuring Daniel Esteban, Conejo Ninja, one of our longtime team members and contributors, and Marci Eiskind, which many people know as one of the organizers of the Go Dev Room at FOSDEM. So they're going to be programming an Adafruit Pi badge. So this is the Pi badge. It's actually, or the Go badge. The Go badge is a Pi badge, but that's been programmed using Go, and that we put a few stickers on. You may have seen those stickers before. And so here is one of our favorite team members, GopherBot, wearing the Go badge. So hopefully next year we'll all be in the real world someplace, and we will be able to get each of the GopherCon attendees one of these badges to program. You'll have to bring your own plushie. All right. So we've been pretty busy, and we even have a new library called Go Bluetooth. So Go Bluetooth is a Bluetooth library that lets you run bare metal on microcontrollers, runs Linux, runs on Mac OS, and even runs on Windows. Yes, even runs on Windows. So the return of the BLE. Anybody who has been to one of our famous GopherCon hardware hack day sessions has been able to program things, vehicles. So you may have seen one of these Sphero Spark Pluses, and you've really, really wanted to program it using your Mac. Well, guess what? GoBot is back. We now are going to be able to program, once again, the Sphero using Go on your Macintosh, Mac OS. Yes, BLE is back, my friends. BLE is back. All right, so check it out, tinygo.org. You can find all the code. TinyGolang on Twitter. tinygo.org is our website, as I mentioned. And thank you very much. I am Dead Program. And this has been an official TinyGo announcement.
Well, thank you, Ron. Do you approve this message?
Yes, I do.
Fantastic. I appreciate that and all the hard work of everybody at TinyGo. And it was obviously great to see you again. Awesome. So that was a TinyGo update from Ron Evans. Really incredible stuff there, especially the Bluetooth stuff at the end, considering that currently this Mac that I'm broadcasting from refuses to run Bluetooth for some bizarre reason. So I might be reaching out to Ron in a little bit. Okay, so up next, we have Horatio Duran. Horatio, do you want to come on board? Hey, how you doing?
Hey, I get to be after the guy that makes robots. Hard to top.
He doesn't make robots so much as he programs them to destroy me.
It's a nice hobby.
It's a living. It seems to work for him. So Horatio, where are you joining us from today?
I am in Argentina.
Argentina, lovely. How's the weather?
Very warm. I'm actually wearing shorts. And having
Nice.
air conditioning so my computer won't overheat.
Hey, you know what? It's November in New England, so I'm jealous. And you're going to talk to us today about writing Jira Cloud plugins, right?
Yeah, how exciting.
Again, it's a living. Nice to have a hobby. So I'm going to turn it over to Horatio Duran, everyone.
Well, hello, everyone. It comes a time in every company's life when you either get acquired or get to the size where you need to write a Jira plugin. It's a fact of life. It's either you integrate with that or I guess with Salesforce. So at a company, we had that exact same conundrum. We had to create a Jira Cloud plugin. So for those who doesn't know, Jira jumped from being an on-premise and hosted by them offering to a pure cloud offering, which is completely different to what they used to have before. So the new plugins are basically just you serving something. So they just embed you in an iframe, or they request you and show you somehow using some embedded JavaScript from them. So it's all you serving basically the content. So we had to create one of those. Most, if not all, of our infrastructure is Go. We have a big API server, which is Gorilla Max. And When we went to look out for the libraries for this, we discovered that they only offered one for Java and one for Node.js. So our first approach was basically we just used Node.js. We built a nice plugin with all the features we wanted. We started serving it, and at some point we realized, hey, we are duplicating API functionality all over the place. So let's fix this. Let's fix this for us looked like let's write the same thing they have in Node.js for us in Go. So quickly, the way you create one of these things, I'm going to go low, sorry. So basically, for Jira, you serve a file called @connect JSON, which describes your plugin and which endpoints, which sockets you want to be, which callbacks you want to receive. And with that, Jira knows how to connect to your server. So naturally, we wanted to do all this in Go and support Gorilla Mux, which is what we were using. So let me go low. So basically, sorry, I lost myself in my own code. The way we decide to do this is by creating a simple struct. So we call the struct a plugin. You just instantiate one of those. And as you see the code right now, this is a plugin. This works as it is. So if you were to run this plugin, it'll serve your plugin. It'll do absolutely nothing, but it'll run it. You could actually install it, and no one could do anything with it. So we implemented every kind of thing you can hook up to it as methods. So basically, you can add lifecycle handlers. You can have things be called when you're installed, uninstalled, enable, disabled. We created a ton of types, so you can deserialize their communication with you into Go types instead of having huge map interfaces. We added a method to add fields. So basically, each invocation of this creates a field in your declaration, and this will in turn create a field in Jira into the issues of Jira. The same way to add webhooks, and you also can pass the handler for the webhook you're trying to add. So basically, you'd say, okay, add a webhook for this and handle it with this function, which is basically an overgrown version of HTTP handler, which adds this to, sorry, you can see my mouse. You can see what I selected, yes. This adds this 2 extra attributes, which basically are what we know about your Jira install information and a simple storage interface. And what we'll do is our plugin will verify that the request coming from Jira is actually coming from Jira. So we store information that allows us to verify every call you get. And that's done automatically by the plugin, but we exported every single helper for that. You can also add web panels, which is basically a way to embed a piece of your content into a Jira issue. So it will show, like, in a part your content. And for this, you have to add your handler by hand, but you can wrap it in the verification if you want so. So once you ended adding all your parts, you just invoke plugin.router. You can either pass a max router or a Gorilla Mux or not, and you get back a router. If you pass a max router, it'll just add it as a subroute. So in your router, you can add extra methods that you'd want to handle. This one particularly serves a basic HTML page for them. And then you just listen and serve on your router. And the result of this is when you go to Jira, this is a playground Jira. You load a string, and here, for instance, this is the web panel I added. And this is the content, which is dumb content. It just echoes whatever Jira sends us. And these are other plugins made with the exact same thing. So you can basically embed whatever you want. And these files were added also with the simple methods we invoked. And if you go to the apps section, there you go. Take some time, sorry. Slow internet on the side. Loading. Great, just in time. You see, this is the plugin we added. It has no more information other than what we declare in the instantiation of the project. And that's it. Go find me in the chat, and I'll give you links to tutorials on how to use this if you'd like to. Thank you.
Thank you, Horatio. I appreciate that. See, that was good. I like Jira. Now you sold me. Well, thanks, and good luck down in Argentina down there. Let's try to stay cool. Well, okay. Seriously, who doesn't like Jira? Come on. I thought that was a really great talk, actually. I really did enjoy that. So up next, we have Jeffrey Payne joining us. Jeffrey, are you with us?
I am with you. What's going on?
Fantastic. I feel like I'm on CNN and I'm like connecting to all my remote correspondents around the world to check in on the status of Go. How's Go over in your neck of the woods?
It's going great. I'm in this is called an office. I don't know if you guys know what these are, but
no, I haven't seen those in ages. Yeah, where's that office located in the world?
It's in Kennewick. It's in Kennewick, Washington, which is where I exiled myself from the Seattle startup world a few years ago. So.
Nice. And how's the weather out there today?
It's pretty good. It's nice.
Okay.
It's because this is the desert side, so we get all the sunshine and the.
Oh, okay. There you go then. That's not too bad then. It's
it's good.
It's better than what the guys are dealing with down in Florida while they're trying to host this conference. So
That's right.
That's great. Right. And you're going to be talking to us about payment terminal firmware, correct?
Yeah, sort of. It was kind of spur of the moment, but we actually decided to write firmware for credit card terminals in Go, and
fantastic.
We didn't know if it would work, but it did. So
well, take it away. I'd love to hear about it.
All right. So my name is John. I'm CTO of a little startup called Blockship. And we got going maybe 2.5 years ago. We're going to build like an entire payment solution, the gateway, the merchant portals, the terminal firmware. And we kind of assumed that we'd write the server-side stuff in one language and we'd have to write the terminal firmware in C++. But we got our hands on the devices that we're using, and this is one of them right here. This is an Equinox Lux 8500. And it turned out that it ran the ARM7 chip, and it's got BusyBox Linux on it. And so even though the terminal manufacturer was pretty scared, we said, we're going to try to write the firmware in Go. And that way it's, we can have one language for everything. We don't have to have a bunch of different teams while we're still small. So we tried it and it worked. But it was pretty challenging. So like this is the device. And this thing is, if you've never worked with devices like this before, this is kind of a sealed garden. You can't SH into this. It is completely locked down. So once you install software on it, there is no way to sort of remote into this device to change anything unless you sort of bring it with you. So, and the memory constraints are like, this is 256 megs of memory, 256 megs of storage. So we had to be really kind of tight and keep it locked down. But, we started the experiment and it worked. And it worked so well that it didn't feel like we were kind of doing something that was sort of a little bit of a weird hack. It seems like the most straightforward way to do things now. And just to give you some data, we're not even using TinyGo or removing the dwarf information from our binaries, and we're only using 16 megs. And that 16 megs binary has to do a lot, not just payment processing. You can customize the logos. You can do contracts. We built our own telemetry because you have to, this stuff goes on the counter in a store somewhere. So you have to be able to do remote debugging and remote monitoring. We actually built our own Splunk forwarder so that we can forward log events from the terminal up to Splunk. We did all of that in Go. We built the ability to update not just our own software on the terminal, but the entire operating system from our binary. So it has to do a lot of things. And there's remote control, all kinds of stuff. So the point of the talk was we weren't sure if we were doing something that was advisable, but it worked really well, and it feels a lot less. It feels a lot more maintainable than I think it would if we had done it in C++. So it's worked out really well. And if anybody finds I don't know if you can use firmware for a bring-your-own bootloader type of scenario. But since we did have a simple Linux distribution to build from, it worked out really well. So I would recommend anybody trying to do, don't be afraid to use Go in an embedded situation. Although based on Ron's talk, it doesn't seem like many people are. But that's basically our situation. I won't take up too much more time, but that's the long and short of it.
Awesome. Thanks, Jeffrey. That was really cool. I love seeing talks where people are doing just really interesting things. I would go. I remember in 2001 going to Java World at the time.
Yeah.
Java 1, sorry. And they were talking about trying to run Java on credit card chips.
No way.
I know, right? It was all the JME was all the rage. But it's really cool to see that Go can start getting really close to that sort of goal.
Yeah.
Which is
well, and the real confession is this is what got me into Go, because we wanted to use one language to rule them all. And so I switched from Java to Go as part of this project because and it's been great. I will never subclass anything again.
Fantastic. Well, Jeffrey, thank you for coming on and showing us what you're all working on over there. Good luck.
Thanks. Bye.
Thank you. Okay. So I got to be honest. One of the things I really like about this whole virtual thing is I don't have to keep running up and down the stage every time our talk ends. So let's bring up our next speaker, Ben Calderon, I believe. Ben, are you there?
Yeah. Hello.
Hey, man. How you doing?
I'm pretty good. I have never felt the imposter syndrome so strongly as right now. But
you'll be fine. Don't worry about it. Ron's not all that great. Trust me. No, you're doing great. Hey, you got a cool looking backdrop. You got a nice acoustic guitar in the background. What more can somebody ask for?
That's my nerd desk. You know, the part that my wife doesn't organize. So that's
Fair enough. I'm in my nerd nest here that my wife doesn't organize as well. So which is quite nice. So welcome. So where are you joining us from?
I'm right now in Cupertino, California.
I've been there many a time.
Yeah, it's ridiculously cold. I recently moved from Tennessee, you know, for all the sun, and then we're in the 30 degrees here. I'm like, what? You're letting me down, California.
That is definitely unusual. Every time I've been to Cupertino, the weather's just been outstanding. In fact, that was actually the only place this year I have flown to.
Okay.
Was Cupertino back in February for a week, and then that was it. So anyway, Ben, you're going to be talking to us today about project structure. Is that correct?
Yeah.
Fantastic. Well, I'll let you take it away. I want to hear all about it.
Thank you so much. So I wanted to share today how kind of like I had my eureka moment about how to organize a project in Go in a way that it could actually grow. I had been using Go for quite a while, but coming from Node.js and from Python, you know, I never saw a compiler telling me, hey, you have circular dependencies or whatever that was. And in this company that it was a side project and now turned in a full-time thing, this was a really big project that honestly, I rewrote the whole thing around 3 times. I inherited a Python code base, and the first thing you do with a Python code base is obviously rewrite it and Go. But in this process, it was really, really interesting to finally come to get a proper structure. And I guess I can call this how to fall in love with interfaces, if you may. I have no slides because I decided to give this talk just about an hour ago. But I wanted to show you guys this pattern that I thought really cool, which I think it's called service pattern. But the idea is that, well, as you guys might know, we often have this package folder in our Go code base in which we have multiple packages. And this was the initial approach that I took, that we took in our company to organize our application. But we realized something very quickly. There were things that, for example, email needed something from the authentication package, and then the authentication package needed something from the email in order to be able to do something. And we had this very, very weird infrastructure, and like trying to solve this, I came across this pattern of repo. I don't know if you guys might have heard about this. The idea behind a repo is that you're able to create an interface in which your application never actually knows what is happening with the database. It just knows that there's a thing called get active users, and it will return this and an error. So wherever you call the repo, the user repo in this case, with this get active users, You don't need to pass any implementation details as this database, or you don't need to ever touch that. The application is the application layer is completely unaware of how the repo is doing this. So we adopted this pattern in order to handle how we manage our database. But we realized that there were other things that we needed to kind of have the application decouple from those layers. And what we ended up doing was end up with kind of like this structure. We have all of these, if you may, services. We have a log service, we have an email service, a front service, and whatever. And all of these services, we just pass down what they need in order to function, let it be the database or the configurations. And then once we initialize these services, we pass these services to our main application. And these services, in order for this to work, also we had to separate the definition of the services, if you may, from the application. Thus, in our application folder, pretty much everything that is here, these models, is just structures defining how things are supposed to, how our data looks like. And the advantage of having this model outside of our applications, or sorry, outside of our packages, is that we're able to use these models pretty much anywhere in the application. We're able to use these inside packages like authentication, or even our user repo. We're able to use the models in the application layer and everything like that. And also the definitions that these packages implement are defined here on service. So let's take a look. For example, this log service is a very simple one. We define this interface, and this interface is just has one method, and it just takes that one element. The place where this is actually defined is here in packages that log. And log, actually, first we have the function that returns that service, which is just an empty structure. But that empty structure is the one that implement this log error method. And thus we're able to have this very nice decoupling. And I hope that I'm not going too fast. I hope that is making sense. But for me, it was a really, really big eureka moment when I actually decided to learn what in the world are Go interfaces and what they can be used for. And I guess one of the best confirmations for me that this structure worked was when we actually brought in another developer, and the other developer, within just a couple of days, was actually able to be productive. There wasn't a lot of questions about where things go, where things are defined, where things are supposed to be implemented. Was just organized. So if you have worked with small Go applications, kind of like tools or whatever, and you start doing something bigger, I think that is a really good investment to just learn why the why of interfaces, because they can really help into making application, separation of concerns, co-organization, and just the ability to make it grow and expand it and modify it and whatever it is needed for the business. So yeah, that's it. Wanted to share my excitement about interfaces.
Well, thanks, Ben. I appreciate that. I know I'm always struggling with project structure, and I think every project I do is like just a little bit different than the last one. As as I go and I hear people like yourself talk, and I go, oh, okay, that's kind of an interesting idea. So I'm still like trying to nail that. It's a moving target, I guess is what I'm saying. So I appreciate that approach to it. Thank you very much, Ben.
My pleasure.
Great. See you around. Thank you. Okay, so we have time for just one more lightning talk before we get back to the main conference. So we're going to bring up Chris Walden now. Chris, are you there?
Hi, yeah.
Hey, nice to see you.
Nice to see you.
Where are you calling us from, Chris?
North Carolina in the USA.
Nice, fantastic. How's the weather down there?
It's super windy. Been storms of leaves blowing past.
Is a
all
storm
day.
brewing?
I don't know if it'd get that far, but
I'm
lots
up
of
in
wind.
Boston. We're getting pretty similar weather. I think it's that tropical storm that's hitting Brian and Eric right now. Is making its way up the eastern seaboard here.
Yeah.
So what are you going to be talking to us today about? Arbor, I believe, right?
Yeah. So I've spent.
Fantastic. I'm going to let you take it away, Chris, and we'll see you back here shortly.
All right. So I've spent the last couple of years working on this open source chat project called Arbor. And Arbor is, to an extent, built out of the frustrations that have been accumulating in me using other chat platforms. The crux of the matter is that in Arbor, conversation is structured as a tree, not as a list of ordered messages. And what this looks like is in your current chat platform du jour, you have your team members talking and their messages are just ordered by time. And maybe your chat platform permits threading so that you can have someone ask, can I get some eyes on my PR? And then this entire conversation can occur within that thread. But that doesn't solve the fundamental problem that if you read these messages from top to bottom, they're not actually coherent because people respond to messages other than the one immediately before them. So when you read conversations in chat, you often spend some amount of cognitive load subconsciously looking at a message and trying to walk upward through the chat history to find what was this a response to. So Arbor is an attempt to fix that by simply asking you to always indicate what you're responding to, so that Arbor actually understands the tree nature of the conversation that you're having. So Arbor knows that things look like this, and then we can actually surface that information to you within our user interface. So what that, well, so we're taking advantage of a really amazing Go technology called GIAO. It was one of the keynotes at GopherCon last year, I believe. But it's a cross-platform GUI development toolkit that you can write pure Go code, super readable, super understandable Go code, and then cross-compile it for essentially any platform that you could possibly want. It's really amazing. And I've really enjoyed working on this project and with its community. But we have used that to develop an application called Sprig, which is mainly developed on SourceHut, but is mirrored to GitHub if you want to check it out. And Sprig surfaces the tree structure of chat. So I'm going to switch what I'm sharing real quick so that you can actually read text. All right, here we go. So this is Sprig. So we can say, if I could type, greet the people out there. So what we've just done is we've established a completely new conversation. We want to talk about something new. And so if we select it, Sprig will tell us information about the tree structure of chat, right? So each of these replies that's coming in from community members are highlighted and indented to indicate these are somewhere in the descendants of this message. And so we can select each one to better understand where it falls within that hierarchy. So this message here is a direct response to me. And maybe each of these, okay, here's one that's not. So this is a response to me saying hi, but one of our community members is asking about this little, I don't know, emote, ask emoji, whatever your preferred term is. So this is what the base level of Arbor's functionality looks like. But we can do some really interesting stuff. Let's say that I really wanted to understand the context of this particular message here without all of the noise. So Arbor understands the structure of the conversation, and we can actually filter everything out to just show this message and its immediate ancestry. And that should be a completely coherent conversation. So yeah, this is how you respond. You choose a message and you hit the reply button, or you just hit enter while it's selected. So you can go to arbor.chat and follow the instructions to try this out for yourself. But this entire interface is 100% Go, built on GIAO. It runs on iOS, Android, Mac OS, Windows, BSD. So yeah, thank you for taking a look.
Wow, that was awesome. Excuse me. That's a really interesting approach. I'd never thought of doing that. That makes so much sense, though. Like, it makes just a ton of sense, Chris. Why doesn't everybody do that?
I hope that at the very least, our presentation's compelling enough that some people try copying it.
Well, it's funny you say that, because Matt Ryer's already texted me saying he's stealing the idea, patenting it, and trying to put a shiny label on it. And I just don't think that's cool, Matt.
Sorry, I got prior art.
Exactly. Well, thank you so much, Chris. I appreciate you being here today. Well, that looks like it's about all we have time for here. We've got just a couple minutes left. So I want to thank all of our speakers. They've done a great job today. Some really, really interesting talks there from all around the world, which is also quite fun there. And I love to see and hear from all those great voices from around the world. And I'm hoping to see and hear more great voices on Friday. So again, I want you to go to gophercon.com, and I want you to check the website there for the agenda for not just the whole conference, but also for the lightning talks on Friday. See when they are where you are. Join us. Please submit a talk. We have quite a few people who didn't get to speak today. We're going to get to hear from them on Friday. So I'm very excited to hear from them. And I'm really excited to have you all join us again. And I just want to say thank you again to all of you for watching, and to the speakers, and to all of our great behind the scenes folks, Heather Sullivan, Julie Williams, Jose LeBoy, and more. So if I'm reading this correctly, I'm very excited because I get to introduce the next GopherCon speaker. I know we've got 2 minutes here, but I'm going to introduce him anyway, and we're going to see what happens. Who knows? He may or may not be ready. We'll find out. So I'm going to throw it over to Justin Walker, who's going to talk about safety using the unsafe package to... Wait a minute. I just want to make sure I'm getting this right, because this is crazy. Using the unsafe package to make syscalls in Windows APIs without SEEEDSTUDIO. Yeah. If you're not going to watch that, I certainly am. Like, that sounds crazy. So everybody, please turn your attention over to Justin Walker now, who's going to show us how to use the unsafe package to make syscalls on Windows. Good luck, Justin.